Hey, welcome back everybody, and welcome to our online students today. What we're going to do is take a look at the periodic table and calculating average atomic masses. Now the periodic table, we're probably all familiar with it or have seen a periodic table. We've got one over here and one over here in the classroom, but that's not the only version of the periodic table. There's other versions of the periodic table that people have come up with. And this on the screen right here is one that was developed by Dmitri Mendeleev. Now, Dmitri Mendeleev is the person who gets credit for discovering the periodic table. And it's not that he was just walking through the woods in Siberia and tripped over a log and said, whoa, periodic table. There are other people that arrange the elements into periodic tables at the same time as Dmitri Mendeleev. And why does he get credit for this? What's so special about Dmitri Mendeleev? And if you watch the video online as the pre-work to this, his mom should get Mother of the Year. If you saw this, his dad went blind working in a factory and left the wife and like 17 children to fend for themselves in Russia, in feudal Europe, right? And so she walks with Dmitri all the way, was it like Moscow? He didn't get into college, and then she walked all the way to St. Petersburg. I mean, she walked with this kid all the way across the steppes of Russia. Now, if you remember your history, Napoleon tried this and failed. The Nazis tried this and failed. There's certain truths in the universe. Never start a major land war in Asia, and never have a battle of wits with the Sicilian when death is on the line. Okay. So now Dmitri Mendeleev gets credit for coming up with the periodic table. And why? Okay, so here's his periodic table. And as we take a look at the left-hand column, so at the very top there, it says group number 1. And you see hydrogen, lithium, sodium, potassium. That looks like the modern periodic table. But then we go down a little bit further, we've got copper. And go, wait a minute, copper, that's not normally there. And so the way he arranged his was based on valences, or that is to say, the things in the first column tend to make +1 cations. And column number 2 tend to make +2 cations. Okay, and he's not the first person to come up with this. Other people did this. But you can see on this periodic table there's some blank spots, like element number 44. There's just a question mark there. And nobody knew what that was. It hadn't been discovered yet. And so he just left it blank, and there's a few other blanks on there. But what made him different, what set him apart, is he looked at these periodic trends and said, someday somebody will discover element number 44. And it will behave like the element above it, aluminum, and maybe a little bit like the element below it, yttrium. And then he went even further and said, okay, not only will it form a +3 cation, but here's the density. And here's what I think the atomic mass is going to be. He made these predictions. And that would have been all fine and dandy. People make predictions all the time, right? I make predictions every time I go to the gas station and I get one of those little cards with the scratch off stuff. I'm still here, so obviously I'm not good at predicting. But he made these predictions, and what made him special is in his lifetime, I believe 5 or 6 of these elements were discovered, and they matched his predictions. And it's not that he just made these things up. He made these predictions based off of periodic trends. So this is why Dmitri Mendeleev gets credit for the periodic table, even though other people came up with similar tables. He's the one who really, really figured out periodicity, or how these elements are going to be related to each other. And no, this is not how the periodic table was developed. That is a different Russian game. Now, on our periodic table, our modern periodic table, we arrange elements based on an order of increasing atomic mass. And atomic mass, that is the number of protons, atomic number, increasing atomic number. So that's the number of protons. So we do it based on the number of protons. And elements in vertical columns have similar chemical and physical properties. So as we take a look at the vertical columns in our periodic table, like the very first group, hydrogen, lithium, sodium, potassium on the far left-hand side, all of those elements have similar properties. They all tend to form +1 cations. They all have similar properties. And then periods. Periods are horizontal rows. Periods are horizontal rows, and we have them labeled here 1 through 7. So like hydrogen is in the first period, lithium is in the second period. And we will later think of these as energy levels. So these are horizontal rows are called periods. And these vertical columns are called groups, also known as families. Also known as families. And some of these families have names. And so on your periodic table, if you have a periodic table handy, you can label these things on your periodic table. So on the far left-hand side, group 1, these are called the alkali metals. Alkali metals. And group 2 are called the alkaline earth metals. And alkali means basic. And they used to sell these things called alkaline batteries. I don't know if they still do or not, or if they still call them alkaline batteries. But what they are is they have a base in them. And so these elements, if you stick them into water, they form bases. They form bases. So like sodium, for example, if you drop sodium into water, it will form sodium hydroxide, which is a strong base. And so these first two columns are alkali and alkaline metals. Now group 16 are the chalcogens, and that's kind of an archaic name. We're not going to deal with that one. That's just, it's one of those things, but that just kind of went the way of the wayside. And then group 17, those are the halogens, fluorine, chlorine, bromine, iodine. Those are our halogens. And then group 18, the far right-hand group or family on our periodic table, those are our noble gases. Noble gases, helium, neon, argon, krypton, xenon, and radon. Now, sometimes people get noble gases confused with Nobel gases. Noble gases are, I am a noble, I shall sip my tea with a pinky in the air, I am better than all you riffraff. That's noble. Nobel is the prize you go to Sweden to pick up for doing amazing, awesome stuff. And I'm still waiting for that phone call. Now we also have our metals and our nonmetals. So on the far upper right-hand side, kind of in the purplish color here in our periodic table, those are our nonmetals. Our nonmetals. And then in the tan color, over on the left-hand side here, most of the elements, those are our metals. And then in between, in green, those are our in-betweener elements. Those are our metalloids. They're somewhat metallic-like, but not completely metallic-like. Kind of go both ways. You can see element number 14. See element number 14 up there? It is a metalloid. This was my favorite element in Spanish class, because the professor would ask questions and I had no idea what he was saying, but I would just say C. So, C, Si, silicon. Silicon is a semiconductor. It kind of conducts electricity, but not a whole lot. It's used in making electronics. It is a semiconductor. It's a metalloid. Now we also have main group elements and then transition elements. And our transition elements, these are kind of the ones in the middle here in the pink. And so if you think of this as being like a bed, there's a headboard on this side and a footboard on this side, and in the middle is where the bed is. That's where your transition elements are, transition elements. And so these are kind of transitioning from one side of the periodic table to the other. And they've got some strange properties. They do some weird things, and we'll spend some time with them, getting to know them later on. Now metals, on the left side of your periodic table, these tend to be shiny, solid. They conduct electricity. They're malleable and ductile. These are good things to put in your notes. I wouldn't write these on your periodic table, but these are good things to put in your notes. Metals are shiny, they conduct electricity, they're malleable and ductile. Malleable, there's one of those $5 words. Somebody help me out with malleable. What does the word malleable mean? Yes, sir. You can bend it. Oh, yes, yes, you can. If something is malleable, you can bend it. Without it breaking, yeah, without it breaking. So you can bend it without it breaking. Yep, yes. You can mold it. You can mold it, you can bend it, you can shape it, yes. So all of those things you can. Now, malleable comes from the Latin malleus, which means hammer. It means you can shape it with a hammer. Ductile comes from the Latin ductus. It's where we get things like duct tape and ducts, aqueducts. It means you can lead it. And that is to say you can string it out like into a wire. Just some fancy terms. I like using these terms in conversations and say, oh, so how was your date? Oh, it was very nice, but I found him quite malleable. You mean you could shape him with a hammer? No. I mean, I could bend him to my will. Yes. All right. Nonmetals. Nonmetals, they tend to be brittle. They could be liquids and gases, could be solids. But these don't conduct electricity very well. They're not really thought of as conducting electricity too much. Excuse me, yeah, the nonmetals don't conduct electricity. And then metalloids, these are kind of in between. They tend to be brittle, they tend to be semiconductors. So kind of our in-betweener elements, kind of our in-betweeners. Any questions on any of that? That's kind of our crash course introduction to the periodic table. And as time goes by, we will spend more time elaborating on this and learning more about the periodic table. It's one of the greatest inventions in the universe. Sliced bread is, like right here, but then there's that periodic table. It's pretty darn awesome. Now, that's our periodic table. What we're going to take a look at next here is the weighted average of elements. Okay, so weighted average. Weighted average of elements. Now, why is this important? Because we learned a little while back that carbon has different isotopes. One of the isotopes is carbon-12, and it has 6 protons. And we know that it has 6 protons because that's the atomic number, and its mass number is 12. That's 6 protons plus 6 neutrons gives us that 12. But when we look at the periodic table, we look on our periodic table, and it looks something like this, where we have a box, and you have a carbon in there, and then you might have in the upper right-hand corner, depending on your periodic table, a 6. There's our atomic number. And then it's got a mass number, and that mass number is 12.011 AMUs. And 12.011 is different than 12. And somebody very eloquently pointed out that this number here is the weighted average of the different isotopes based on their abundance. And so how does that work? How can we do the math on this? So I'm going to show you the trick for figuring out the average atomic weight or mass of an element. Did I? No, okay. All right, so we're going to take a look at neon. So neon has 3 different isotopes. We have neon 20, we have neon 21, and we have neon 22. Yeah, 3 different isotopes. And as we can see here, each of these have their own masses, roughly 20, 21, and 22. And then they have an abundance, a certain abundance here. Like what percentage of the neon that you find out there on Earth is going to be of each of these isotopes. Now, if you want to figure out the average atomic mass of neon, we say the average atomic mass of neon. What we're going to do is we're going to say average is going to be equal to some kind of mathematical relationship between the masses and their abundance. So the way that we'll do this is we're going to take the mass times its abundance of each of these isotopes and add them together. So I'm going to start out here with neon 20. So neon 20, I'm going to say that that is 19.9924 units, and that is times its abundance. And I'm going to take the abundance, I'm going to turn that into a decimal. So that 90% becomes 0.904838. And that's our neon 20. So I'm going to go neon 20. And I'm going to add that to the next isotope here. That's going to be our neon 21. Neon 21. And so that's going to have a mass of 20.9940 times its abundance. Now this gets tricky. Its abundance is 0.2696. And if I turn that into a decimal, that means I have to move the decimal how many spots over? 2 spots. Okay. So it's a little tricky there. I'm going to go 0.002696 and then add that to neon 22. And so that's going to be 21.9914 times 0.092465. So there's the math on that. And then if I just multiply each of these numbers, then add them together, I'll end up with some number. Now, if you've got a calculator, it's a good idea to try working through this.
A few moments later.
Now, before we reveal the answer, or maybe just confirm the answer, just looking at these numbers. Neon 20 makes up 90% of neon. So that isotope makes up 90%. This here makes up less than 1%, and this one here, neon 22, makes up about 9%. So that being the case, whatever number we end up with should be fairly close to 20, since it makes up 90%. Does that make sense? It's just kind of a way of checking our math. Okay. So now, if we did our math and we punched all of these numbers in and we get some number, okay, you've got a calculator in front of you. Yeah, what'd you come up with? 1799. Okay, atomic mass units. Thank you. Thank you very much. Okay, so that's fairly close. That's fairly close to 20. So that kind of fits what we surmised. All right. Is there another way that we could check this? Is there another way that we could check that number? The periodic table. Theoretically, what's on the periodic table should match closely with this, right? If we did our math right. So if I look up here and if I find the element, oh, obscure cultural reference, the element that says ni, or is that nickel? That might be nickel. Well, okay. You know, sad day. Did you see one of the Monty Python people passed away last night? Yeah, that was sad. One of them was from Minnesota. Did you know that? Yeah. Okay, so neon, it says up there 20.1797. Yeah, pretty darn close. I think we did okay. I think we did all right. Okay, stupid story for you. You see Mendeleev there? Does that look like the type of person you'd want to run into in an alley? Yeah, kind of a shady looking character. It turns out he went to university and trying to remember how this story went. He ended up falling in love with one of his students and proposed to the student. And I think they got married. And you know, okay, that's a little creepy and weird, right? Okay, that's not right. But what made it worse is he was married at the time. Yeah, that's what you call a no-no. Dating your students, bad, and then yeah, extramarital marriages. Okay, that's called polygamy, and that's frowned upon in most cultures. So, yeah, kind of a shady-looking character. Anyway, okay, what do you want for Christmas? Periodic table, darn right. Fits right like in a stocking. You could like roll it up right. Okay. Maybe your Christmases were different than mine.